In this video, I will explain how to find the early start and the early finish of each activity in a PDM network diagram. So let's consider the following project right here. We have some project with 7 total activities. This table shows the activity names, the predecessor to each activity, and the duration of each activity. Now, I've gone ahead and drawn a basic PDM network diagram here that shows the flow of each of these activities. So within each of these boxes, the top middle square shows the activity name, and the bottom middle square shows the duration of each activity. So for example, in this first box here, we can see that activity A is the very first activity of this project, and it has a duration of 2. So for this video, let's just assume that's 2 days. Now, what we want to do is we also want to add what is the early start and the early finish of each activity. So for each activity, the early start, we're going to write that in the top left corner, and the early finish we're going to write in the top right corner. Now, the early start, that just represents the earliest that an activity could start, assuming that none of the activities preceding it have been delayed at all. And the early finish simply represents the earliest day that a project could finish, again, assuming that there are no delays in any of the preceding activities. So let's go ahead and find the early start and early finish of all of these activities in this project. So we'll start with the very first activity, activity A. The early start, whenever you have the first activity in a PDM network diagram, the early start is always denoted with a 0. Now, sometimes students get a little bit confused with this because they say, well, shouldn't this be a 1? Shouldn't this start on day 1 of the project? But what you must understand is that when you write a value like this in the PDM network diagram, this represents the end of that particular day, or it can also represent the very beginning of the next day. So when we write a 0, what we're really saying is this activity can start at the very end of day 0, which can also be interpreted as the very beginning of day 1. So that's why we can't write a 1 right here, because if we wrote a 1, that would indicate the end of day 1. And again, activity A can start at the very beginning of day 1. So that's why we write a 0 right here. Now, to find the earliest that project A could finish, all we do is take the early start and add the duration. So 0 plus 2 is 2. So we'll put a 2 right here. So this tells us the earliest that activity A could finish is at the end of day 2. Now what we do is we take the early finish and we just write it as the early start for the next activities that activity A leads into. So activity A leads into activity B and C. So for both of these, they get an early start of 2. And again, to find the early finish of each activity, just take the early start and add the duration. So for activity B, that would be 2 plus 6, which is 8. So the early finish of activity B is 8. For activity C, the early finish would be 2 plus 4, which is 6. Then moving right along, we can see that activity B leads into activity D. So activity D, the early start is going to be the early finish of activity B. So we'll write an 8 right here. And the early finish of activity D is simply going to be 8 plus the duration of 6, which is 14. And for activity E down here, we'll take the early finish from the preceding activity, so activity C, we'll make that the early start, and the early finish of activity E is 6 plus 5, which is 11. Now, for activity F, this one becomes a little more interesting. We can see that it has 2 predecessors, so both activity D and activity E both have to be complete before we can do activity F. So the question becomes, do we take the 14 or do we take the 11 and put it as the early start for activity F? Well, if we just think about this logically, the earliest that activity E could finish is on day 11, but the earliest that activity D could finish would be day 14. And remember, we need both of these activities to be finished before we can start F. So because of that, we have to take the larger of these 2 values. So that would be 14. So we'll write a 14 right here. And another way to think about that is that even if activity E finishes up on day 11, we still have to wait all the way until day 14 for D to finish up before we're allowed to start F. Because again, D and E both have to be complete before we can start F. So that's why we put a 14 right there. Now for activity F, to find the early finish, we're going to take the early start plus the duration. So 14 plus 4, that's 18. And activity F leads into activity G, so the early finish will just go to the early start position. And lastly, the early finish for activity G will be 18 plus 2, which is 20. And 20, this value right here, this shows us the earliest that this entire project could finish would be 20 days. And one last thing that I should mention is that this method that we just used to find the early start and the early finish is known as forward pass. And the reason is because we start at the first activity and we move forward through the network to identify the early start and the early finish of each activity.